In this proof, we start by writing the given information, which was 3 times the quantity 4v minus 1 minus 8v equals 17. Now you might be tempted to start too soon and say, oh, I'm going to distribute, so this will be the distributive property. Don't do that. In fact, what you're doing is saying, this was given to me, and in the next step, when I distributed, it was okay to write statement number 2 because I distributed to get there. If I could spell distributed. So I just used the distributive property to write that statement. So think of this line right in the middle as a because. So you're saying statement number 2, 12v minus 3 minus 8v equals 17 because the distributive property got me there. And then in the next step, 4v minus 3 equals 17 because I substituted or used substitution to replace 12v minus 8v with 4v. And then I added 3 to both sides, so I wrote the statement 4v equals 20 because the addition property says it's okay to do that. And then the last step was I divided both sides by 4, so v equals 5 because I can use the division property. So that's what that proof would look like, and that's what the explanation would sound like if you were to hear it. Now the next proof gets a little bit trickier when we start working with lengths of segments, but we don't write any numbers. We use the letters, like AB refers to the length of AB. CD refers only to the length of CD. But those still count as numbers, and we can use addition, subtraction, multiplication as numbers, even though we don't know necessarily what those numbers are. So let me walk you through this one too. The given statement says AB is equal to CD. All right, step 1, got it. That's what you told me. When you tell me things or when I figure things out, I like to mark the picture. So I'm going to say AB is equal to CD. I'm going to mark them the same so I can see that. The next statement says that AB plus BC is equal to BC plus CD. Now that may look like the segment addition postulate, but it never actually said that it was equal to the whole thing, AC. So I've got to figure out what's actually happening in step number 2. Well, the AB is still there from the first statement. The BC is still there. I'm sorry, not the BC. The CD is still there from the first statement. So what really changed from statement number 1 to statement number 2? I added BC to the left side, and I added BC to the right side. So all I really did was made an addition of this middle segment BC because the addition property says that's okay. Now in the next statement, I see what I thought. AC, the whole segment from A to C, is equal to AB plus the other part, BC. Well, that's the segment addition postulate that says it's okay to add those two pieces together to equal the whole thing. And then the next statement says BD, so from B all the way to D, is equal to BC plus the smaller part of CD, which is another segment addition postulate, adding the two pieces together to equal the whole thing. And now here's where you got to pay real close attention. Let's go back into our statements and look and see what's happening. We're actually replacing something that's all the way back in statement number 2 with things that we wrote down in statement number 3 and number 4. This AB plus BC was equal to AC. So we're going to replace that with AC and write that for statement number 5. And this BC plus CD is equal to BD. So in statement number 2, we're going all the way back to 2. We're going to replace that expression of BC plus CD with BD. And now we have a new statement that says AC is equal to BD, and that's what I wanted to prove. Well, I replaced things in another equation, so it's not the symmetric, that just flips things around, and it's not the reflexive, that just says A equals A or B equals B. I replaced things. That would be the substitution property, would justify why it's okay to say that AC is equal to BD.